In this little short session, we're going to talk about Porch from Nokia and how it can be used to compose packages, compose workloads from upstream packages, then configure those configure and customize those packages and deploy them out to loads to a huge amounts of Kubernetes clusters out in the Cloud RAN. So my name is Fallon from Ericsson, and
hi, I'm István from Nokia.
Okay, so I'm very aware that we're standing between you and the end of your day and maybe a pint of warm beer, so we'll move on quickly here. Okay, so what's the problem? Really, it's a scale problem that we're dealing with here. In the Cloud RAN, we're going to have a lot of clusters. And maybe those clusters are going to be resource constrained. Maybe they're not going to be that different from one to the other, the customization for one, but you could have a cluster per site. You could have a cluster per base station, so you could be getting up into thousands or even tens of thousands of clusters very, very quickly. But we're lucky. We have two wonderful pieces of technology to help us to solve this problem. We've got Kubernetes and we've got GitOps. But we have to do some things to Kubernetes and GitOps in a way that stretches them a little bit. Now, I'm not a big fan of Telco Telco being an exceptional or different sort of software domain to other things. I was listening to some of the talks at the Edge talks this morning, and they the manufacturing seem to have some of the same problems as we have in Telco. So we should kind of avoid that. But at the same time, we probably have to use these technologies in a slightly different way to which they were envisaged. And so we have to, engineer that. I think earlier on, when in some of the earlier talks, Wim and Ashan were talking about some of the advantages and limitations of Kubernetes when it comes to this domain. And I think in Porch, we address some of those, maybe not in as general a way as what Kubernetes does or will do, but we go some way to doing that. So let's dig into the problem a little bit more. So in the Cloud RAN, you're going to have thousands of Kubernetes resources that you've got to configure for the various workload clusters that you're going to have out there. You're going to have tens of thousands of clusters. Then you're going to have to build up the workloads for the clusters from upstream repos, from upstream Kubernetes manifests, with KRM that's coming from open source, KRM that's coming from telco operators' own internal private repos. Even us vendors will probably throw in a package or two, and then you might have some third-party software suppliers for things like databases or whatever. And you've got to put all of these together into workload clusters, compose your workload packages, maybe for the various types of nodes, and then you have to customize those for the particular nodes. And that's, then as well, if you looked at, say, the Silver presentation earlier, you see that there was some manual intervention to merge things. Really, you'd be talking about a huge amount of merging different commits to repos if you're going to do all this manually. So there's a real need for automation here. We need to have automation of the composition of workloads, automation of the customization of the workloads, and also automation of the deployment of the workloads using GitOps. Okay, so Porch. What's Porch? Porch is a system that originated in Google and was donated by Google to Nokia about a year and a half ago, something like that. Yeah. And it ticks a lot of the boxes here to answer some of the challenges that we need we have in this domain. It gives us management of package repositories, so you can have upstream repos, and you can have, where your source packages are. You have downstream repos, which are the hooks for your GitOps infrastructure to hook into. You have discovery of configuration packages, so you find Porch as an upstream repo. It'll find all the packages in there for you. It handles CRUD of packages. It handles versioning of packages, so version 1, version 2, version 3, boring stuff, but very, very important. Package customization with package variants and package variant sets, and that's something that István is going to talk about. That's one of the really cool things in Nephew, and he's going to talk about that in a minute. Then another cool feature is evaluation of functions on package resources. In Porch, you can specify not one, but chains of functions and apply those on KM resources. So you can use wildcards, you can use functions that takes in a collection of KM resources, as a hash map really, operates on it and passes it out again. And that's a really strong and interesting feature. Then you have an approval flow, so you can propose and approve packages, and then you can deploy them into GitOps, where it's picked up by maybe Argo CD or Flux or config sync. Okay, so what have we done to Porch in the last, say, 2 releases? Well, one of the things is we've put in some performance improvements because, as you know, your maintenance window in the telecom world is very short, so we did some fine-tuning so that when it's deploying packages to the GitOps mechanism, it can do it in a very short time, and it's kind of in a big burst rather than spreading it out over a long period. Where minimization, we did some improvements on the data consistency because Porch has to map the information the meta information that's in Git with what's in Porch and etcd. We've improved that a little bit to make inconsistencies happen less, and also when they happen, we've improved the resolution of those. We're introducing a database so that when you're actually doing your package composition and your package customization, you don't need to go to Git at all. You just store the results in a database, and it's only when the package is ready for deployment that you go to Git, because there's Git operations on Git are very expensive and take a lot of time, and also they don't have ASAD characteristics and things like that. Okay, and then we have already got support for private repositories and support for upgrade. Some of the learnings we had here: Porch is a very cool, innovative, I always have trouble pronouncing that word, but complex piece of software. Making Porch production grade, it took lots of thought, it took some time, and it also took lots of energy. Porch is continually evolving, so it's a smallish but an active community. We're adding features to it, but more importantly, we're adding kind of the issues or the non-functional things, resilience, scalability, all of those sorts of things are what's going into Porch now. There's no magic formula for this sort of work. It's the application of excellent engineering and wonderful teamwork that's helping us here. And now I'll hand over to István to talk about some of the cool...
Thank you, Liam. So don't worry, I am absolutely aware that I am literally the last man standing between you and your well-deserved beer, so I will try to be brief and efficient at least. But first, let me assess you how useful this talk will be to you. Just by show of hands, how many of you are using GitOps right now in your company, or something that you call GitOps? No matter what. That is a lot of people. Okay, how many of you are planning to implement GitOps, an automation system based on GitOps principles? Okay, so there are even some people added. Okay, perfect, that looks nice. So in the next part of the talk, I will try to answer the question, okay, but what does Porch actually do? How is it useful for you? So those of you who answered to yes at least one of my questions, hopefully will go home with some knowledge about a tool that you can use to build your GitOps-based automation system. And if you answered no for both of my questions, I hope that you may at least reconsider the feasibility of building such a system. So you might think after this that it is easier because we have a tool for you that does something, that makes it easier. Okay, so in order to achieve the scale that Liam talked about, automation is not a nice-to-have feature anymore. It is a must. I think we can agree on that. So you cannot maintain applications in 1,000 Kubernetes clusters, even semi-manually. So, okay, let's say you agree with this and you start to build your automation system. one of the first problems that you will have to solve, there are multiples, but one of the major problems that you have to solve is to take a generic blueprint and turn it into 1,000 deployments that are similar to each other, but slightly different. And Porch can help to achieve this the following way. So by now, it should be evident that Porch is a tool that helps you build GitOps-based automation systems. So it is a building block of such systems. So it is not a surprise that for us, this generic blueprint is represented as a package. In our case, it is a KPT package. If you don't know what a KPT package is, don't worry. It is just a bunch of YAML files stored in Git. Each of those YAML files are containing Kubernetes resource manifests. That's all you have to know. So basically, it is a list. You can imagine a KPT package as a list of KRM objects. By KRM, I mean, of course, the Kubernetes resource model. A list of KRM objects stored in Git. And what Porch can do to you is to take this package that is a generic blueprint and turn it into 1,000 slightly different deployment packages that will each result in a deployment sooner or later. A deployment of something, a deployment of an infrastructure element like a Kubernetes cluster or a virtual network, or it can be a deployment of an application. It can even mean the deployment of a configuration fragment, and by that, of course, I mean to apply more or less the same configuration to 1,000 already running applications. So it can be anything that can be deployed from a generic blueprint. So what Porch does is to take this package and it is able to generate 1,000 slightly different variations of it, and then you can use those packages to do the actual deployment. That, of course, implies that in order to do an actual deployment, you need all of the information that is required to do that particular deployment already in the deployment package. Of course, in order to be, I forgot that this process we call fan-out. So when you generate 1,000 variations of one package, one blueprint, that is what we call a fan-out. That is one important concept in Porch that Porch helps you to do. In order to be able to do 1,000 variations, of course, you have to be able to do just one. If you can do one variation, then just repeat this process in a loop 1,000 times and you get 1,000 variations. So that is, of course, easy. Porch provides you a tool to create such a slightly different variation from a blueprint package to generate a deployment package, and this is called the package variant. The package variant takes the blueprint package, it applies a list of transformations or mutations on that package, and generates the deployment package. The difference is that the blueprint package is a well-formed package. It is in a canonical form, meaning that, for example, it follows the don't repeat yourself principle. It is dry, meaning that even if some parts of this blueprint will be deployed multiple times, it is not copy-pasted multiple times. That is, however, of course, not true for the deployment packages. We already seen if you have 1,000 deployments of the same thing, then you copy the same thing 1,000 times. They will be slightly different, but most of them will be the same, and we still copy them. So they are not following, deployment packages not following this dry principle anymore. So we call them wet. It can stand for write everything twice, but basically it is a nice way to see that we are going from a dry blueprint package to a wet deployment package. So we affectionately call this process the hydration process. And after that, if we have a deployment package that is fully specified, modified to contain all the configuration, all the information that is needed to deploy it to a particular target environment, then we can use a GitOps tool like Flux CD or Argo CD, to take those Kubernetes resources from the deployment package, synchronize them to a Kubernetes cluster, and of course, from then on, all the Kubernetes controllers running on that cluster will take over and do actually start the pods of the application, or will actually create the Kubernetes cluster or the infrastructure element that is described originally by the generic blueprint package. Of course, if the only input for a package variant would be just the same blueprint package, it would be very hard to generate 1,000 different variants. So of course we need more inputs to differentiate between the variants. That only means that all of these transformations that the package variant will apply will get some input from the users directly, or higher level automation layers, or even new business logic from higher level automation layers. It will combine all of these together, create the deployment package, and since this is a Kubernetes controller, anytime any of the inputs changes, it will recalculate the deployment package, and that will trigger the synchronization to the cluster, and that will trigger, in turn, the actual reconfiguration of the already created something, infrastructure element, application configuration, whatever it is. Okay, so we talked about, so that is one thing that Kubernetes, Refio and Porch can give to you. But there is another aspect of Porch. So that is not the only thing that Porch will provide you. Other than generating variants of packages of blueprints, another aspect is related to Kubernetes controllers. If you are attending this conference, I think it is safe to say that you already heard about Kubernetes controllers. You maybe even you have maybe even written some. I can even assume that you think that building out complex automation systems out of these simple, independent reconciliation loop, you think that this is a good idea. And I would agree. I totally agree. I think this control plane that was mentioned multiple times today is a very good idea in Kubernetes. However, I just showed you that it is viable to store your Kubernetes resources in Git instead of storing them in etcd in the Kubernetes cluster. How can you add additional higher level automation on top of your resources that are stored in Git? And that is where Porch can help you. That is what Porch can also help you with. So this is how a traditional Kubernetes controller works. It fetches some desired state from the main Kubernetes API server. That in turn will fetch it from etcd. Then the controller also fetches the actual state of the world. Some of this will come from the main API server. You know all of this. And then we will even write resources via the API server into etcd. Of course, this doesn't work anymore if your resources are not in the etcd but in Git. And this is where Porch comes to the rescue. This is the second aspect of Porch that I want to talk to you about. Basically, Porch can give you a Kubernetes API that allows you to manipulate all of those Kubernetes resources that are stored in Git. And that way, your preferred Kubernetes controller development environment will still work. You can still use Kube Builder, KOP, whatever you use. Normally, Porch will give you a similar interface that the Kubernetes API server provides to you and will manipulate all of those resources that are in Git. How well we are in time? So, okay. We don't have, I expected that we won't have time for this slide. And these are just a list of principles that Refio and Porch was built on. These are the config as data principles, and I will not read them out because we do not have time. I just want to interpret two of those. So the first one is basically reads that we recommend to you that if you are building, for example, a telco network or a Kubernetes-based automation system, please use KRM as your unified resource model. I think in this context, this is quite evident. And I want to pick the third point on the slide as well, that can be read in a way that please do not use packaging formats that uses templates, that like Helm. When the business logic of generating contents of the package is interleaved with the actual data. In the middle of your Kubernetes resource manifest, you have these curly braces with ifs and fors and function calls in it. Those kind of package formats are very, very hostile to automation. And that is the third point about. Okay. Do you want to say the final words regarding the future?
Yeah, just very, very quickly, just to give you an idea of some of the things that, this is just some of the headline items. There's a load of things that we'd like to do in Porch. But the first one is update, better support for three-way merge. For example, that's if you have, say, changes in the upstream, and then you have changes and configurations that you've made. How do you correctly merge the changes in the upstream with the changes in the configuration changes you've made in a nice way? Anyone that's done a git merge will know what that problem is. We will not reinvent Git here. We're going to take a kind of a sensible compromise type approach. Efficient internal storage. I talked about this already. We're working on this now. We're going to only interact with Git when we're actually when we actually have packages ready for deployment. Up until that, they'll be stored in a relation database. Asynchronous API operations. The Kubernetes API server has a hard limit of 34 seconds for all operations, and all of the operations in Porch are synchronous at the moment. So in other words, you call it, it does everything, and then it returns. And if you've got long mutation pipelines, or you've got a very big package or expensive package that you're pushing to Git, it can time out. Now the operation usually will complete anyway, but it's really confusing for the users. So we're going to make it asynchronous and kind of act like everything else in Kubernetes. In other words, it'll be, yes, sir, we have your order, and we'll come back to you when it's ready, and you can check the status in, kubectl or whatever, rather than today that it comes back and says, yes, it timed out. Make the KRM function execution faster. Today, the mechanism for KRM functions execution is pretty complex. We think more complex than we think we can simplify it a lot. We'll be working on that and much more. We want your help. If your interest is piqued by what we've talked about today, come to talk to István or myself. Then we've got all the resources there. We're a friendly community. We'd like help with development, help with testing, help with documentation, or even help with telling us what we can do better. That's it.
Exactly. Any contributions welcome.
Absolutely. So, with that, thank you. And if you have any questions, please speak now, or you know the rest. They'll bring a microphone to you.
You can use those.
Thank you. What is now the biggest difference between Porch and plain Helm charts?
So Helm charts and Porch are not the same. I mean, they are not in the same category. However, I understand the question. I understand that I had this half sentence about a guidance not to use Helm charts. So that is literally at least a half an hour presentation why I personally advise against Helm charts. But the very gist of it is that when you start to make Helm charts, eventually you will end up exposing anything, all the parameters that are in the Helm chart, meaning that literally you have a deployment Kubernetes resource in the Helm chart, and all of its fields can be overwritten by values.yaml, and that loses any abstraction value that the Helm chart provides. Actually, you are writing a deployment object in the values YAML that is structured differently than you used to, so it doesn't make any sense. So that is over-parameterization, and losing the abstraction value of it. It's losing the abstraction value. And the other thing that I also mentioned is that it is hostile to automation. What does it mean for me? Helm charts were designed to be modified, written and changed by humans. So, but that is exactly the opposite what we are doing here. We have packages that we can at any time parse. I just told you they are just Kubernetes resource manifests that we can, machine, an algorithm can read at any time and apply modifications on it. At least with traditional computing, you cannot even parse a Helm chart before rendering. After you rendered it, it is okay. But before rendering, you cannot even parse it. And it is very, very hard to write an algorithm that makes changes in the resources that are in your Helm chart, again, without rendering it. Still, having said that, so my recommendation is that if you have a greenfield project and you can allow not to use Helm chart, but please don't. On the other hand, both of us are from the telco industry. We created millions of Helm charts. We invested, I don't know how many, but a lot of money in Helm charts. That is a technology that will be here for years to come, and that we will have to support, including in FAO. In FAO, we have plans how to handle Helm charts. That's it. I promise you just 2 sentences. I think that is the short version of what I wanted to say.
Yeah. Go ahead.
You have time?
Yeah.
Hi, this is Anas Alouche from Deutsche Telekom, Telco Cloud Architect. First of all, nice talk, but I would really like to see this part of the upstream products of Ericsson and Nokia. And why I'm saying this is because I was leading the, let's say, NIFU community effort from Deutsche Telekom part with my colleague Bernard between 23, 24. And we took it for a ride, or let's say a road trip between all the vendors, including Nokia and Ericsson. And let's say, in summary, they were not excited at all. They were telling me, we have our own Helm charts, exactly as you said. We invested a lot. We went to them from the angle of, let's create operators for network functions of telco cloud. So UPF, AMF, CU, DU, yeah? So that didn't work well. Then, because we were having a lot of conversations also with Google, we said, let's drill down to Porch, KPT, and see these components. First of all, config sync is being kind of let go for a lot of issues in it. KPT is, let's say, fine, but Porch is an extremely complex piece of software that is today buggy according to our own tests, yeah, our own Deutsche Telekom tests. Of course, we understand that we like Nephew, the idea, we like it, we understand its power, but we were also lacking a lot of support from major vendors. Also, we saw that people in the community just want to use it, but they are lacking the spirit of really contributing. And this is where this is why I said, if we can have this part of your upstream product, somehow that means you have some engineering power behind it. And then the idea is already in an acceptable phase in DT, more or less. But yeah, we more or less now parked it for the time. Yeah.
Thank you for the very detailed questions, first of all. I try to remember. There were a lot of things that you mentioned that I tried to...
It's not a question, it's just a statement, yeah? Just for updating.
Yeah, I try to react to whatever I remember that I wanted to react to. First of all, yes. First, you mentioned you already tried Porch and it was disappointing. We also tried Porch and it was disappointing. One thing that I can tell to you that both Ericsson and Nokia now have dedicated people working on improving Porch. We are in the middle of this process. Liam, on his last slide, listed some of the main things that are not ready yet. These are very important parts that we are working on right now. They are in progress, but they are not ready yet. So I wouldn't even say that please try the latest version of Porch, I would say that please try Porch release 5 in half a year, and hopefully, I very much hope that your experience will be different in the terms that the functionality it provides will be more or less the same, but it will actually work.
Yeah, I think there's dedicated teams working on it now. If you look at I'm trying to put it up on GitHub, it's kind of under pressure here, but if you look at the record for the last, say, 6 months, you'll see a big uptick in the amount of contributions and issues that we're solving in Porch. It's a lot better now in version 4 than it was, say, in version 2. Version 5 will be better again. I think in version 3 or 4, it was more to, we fix small things that were causing a lot of big problems. Now we're getting to solving the bigger things that are solving even bigger problems, maybe. So I'd say give it another try. Maybe give us a,
Okay.
Talk to us off.
One sentence to you. You also mentioned the Porch wasn't good enough to handle real network functions. I would say that please wait for what you also mentioned, nephew releases from vendors that are not open source projects anymore, but production grade products that comes with some guarantees. And we are working on it, and that should be able to handle real-world network functions based on the same code base. So I think it is not an accident that both of our companies are putting effort in making Porch better. Okay, that's